Okay, I just wanted to talk briefly about the lethal dose 50% or the LD50 as well as the ED50. So today some of you made some graphs in class, but for the exam you just need to be able to identify the LD50 or the ED50, be able to give a definition of both, as well as identify substances that have a high toxicity versus a low toxicity based on their LD or ED50. So this was the definition you saw in class. Dose that is lethal to 50% of a population of test animals. And I stress to you that test animals is really important. There's an FRQ out there that was given a couple years ago where if the students gave this definition as just 50% of a population, they did not receive the points because they had to somehow show that they understood it was not done on humans, that this is used on lab rats, mice, guinea pigs, animals. So this is your definition. Dose that is lethal to 50% of the test population. We talked about how it was reported in milligrams of toxicants, usually per kilogram of body weight, and I told you that the smaller the LD50, the more toxic the chemical, the greater the LD50, the less toxic the chemical. It's exactly what we saw in class. I also showed you this graph here. So you need to be able to identify the LD50 on a graph, and this is something you can use your textbook for because you have pictures and you'll see another example from your textbook. But on your y-axis here you have percent lethality, so it's the percent of the test subjects, like I said, mice, rats, any small rodent that is dying from this dose of whatever it may be, and then we have on our x-axis the dose here. And so on this graph, we happen to have two LD50s that are graphed. And so you see a blue line and a purple line. And the way that you would identify the dose that is going to kill 50% of the test population is you would look at your y-axis and you would go up to 50%. From here, you would go to the line. If we wanted to know the LD50 of the blue line, there are no numbers here right now, but you would go over to the blue line and you would go down. And this dose right here represents the LD50. So the LD50 is right here. The LD50 of the purple line, go over to the purple line, go down, so it's just a different chemical or toxin or toxicant. And we would identify the LD50 as right here. Again, also on the x-axis, so this is going to be a dose. From the last slide, you wrote that the lower the LD50, the more toxic the chemical. So if you had to pick a line here, which one is representing the more toxic chemical, the answer would be the blue line because the LD50 is less than the purple line. We said these exact same things in class on Monday. If you look here, this is from your textbook. We looked at the same slide as well. This is showing you LD values for selected chemicals. We have aspirin all the way down to strychnine. If I asked you on this table, tell me the chemical that is most toxic on this table, you would tell me it's strychnine. Again, the lower the LD50, the more toxic the chemical. We know that it's toxic to whatever animal was tested, so administered orally to rats, and we use this information to extrapolate and extend it to humans. So we also talked about why that's a problem. If I asked you the chemical here that is the least toxic to these lab rats, you would tell me aspirin. Again, we try and use this information to extend it and to extrapolate it to humans. You can see in between we talked about caffeine. I probably used cocaine in our example. Nicotine, again, this is administered orally, so these aren't injected or used in a gas form. Then we talked about the ED50. So you wrote that down, what the ED50 is. Again, that's the effective dose. So the LD50 and the ED50 can both be graphed on a logarithm scale here, and they both look very similar. The difference between them is that the ED50 stands for the effective dose. So this isn't the dose that's killing a population. This is the dose that for 50% of the population is showing whatever the desired response is. So I gave you the example of Ambien and sleeping. And so here we can use that example where we have this line here. It was done on test subjects, or it could have been done on humans. But we have this line here for our ED50. And if we wanted to know, if you wanted to find the ED50, just like before, you go up to 50%, over to the line, and down. That's the ED50. Some students say, well, how am I supposed to know if you're asking for the ED50 or the LD50? That will be given to you in the problem. It will say the ED50 is on the following graph, identify where it's located. Or the LD50 is on the following graph, identify where it's located. So again, as long as we're talking about 50%, we go 50% down, and this is the dose that is going to represent the effective dose of, we could say, Ambien, for example. So 50% of the population fell asleep at this dose, so half of the population. Now the threshold, which we also talked about, is the maximum dose where there's no measurable effect. So here is our line that comes off our x-axis, and the threshold would be right here. It's the maximum dose where we see no person or no test subject sleeping here. So nothing is going to be sleeping, and that's the dose right before the first person or the first animal falls asleep. So it's the maximum dose with no measurable effect, and that's the threshold. You should be able to identify that as well on a graph. It's right before that line lifts off the x-axis. If you guys made the graphs today, you know it's the line right where we have the dose of whatever substance it was that actually affected the population. So here it's pretty easy to identify. It's right here. So you should know that definition as well. So this stuff is pretty simple. Just make sure you're looking at it in your book. Make sure you're reading, and make sure you're going over your review sheet.